All right, guys, welcome to Precalculus 2.1.3. So we're going to be talking about how we can transform functions again today. So to start off, we are going, sorry, there's a fly in here. It's been bugging me for a while. All right, we're going to take a look at this resource page. Basically, that's going to be the entirety of problem 30. So I printed one off so you can kind of follow it along there. So it's a little bit harder to kind of have you just do it on your own. So we're just going to kind of do it together for today. So it's kind of like this. So we have a graph here. Now we're going to try and translate this graph into a table. So we have the given x values here. So we're going to get the corresponding y values or f of x values, however you prefer to see it. So at -5, I'm here at 1, 2, 3. At -4, I'm at -1. At -3, I'm at 0. At -2, I'm at 1. At -1, I'm at 2. At 0, I'm at 1. At 1, I'm at 0. 2, it looks like I'm at a half. And then at 3, I'm at 1. At 4, I'm at 1.5, or 3 halves. And then at 5, I'm at 2. So there's my y values that are going to correspond. Again, I could think of this as a 0.5 and a 1.5 if I preferred the decimals, but I'll just leave them both for right now. Okay, so now we're going to take a look here at A. So A, I'm going to put in my f of x as they were right over here. So that's 3, -1, 0, 1, 2, 1, 0, 0.5, 3, 1.5, and 2. Okay, so that is there purely as a point of reference for me. So now if I want to take my function and do f of x minus 4, right? What's that going to do to it? It's going to take my f of x value and then just subtract 4 from it. So they've already done one of those for us. 1 minus 4 is -3. Well, let's do that for all of these. 3 minus 4, -1. -1 minus 4, -5. 0 minus 4, -4. 1 minus 4, -3. 2 minus 4, -2. 0 minus 4, -4. 0.5 minus 4, -3.5. 3 minus 4, -1. 3 should be 1, not, yeah, it's 1, not 3. That makes more sense. Okay. And so that's going to be -3. And then 1.5 minus 4 is going to be -2.5. And 2 minus 4 is going to be -2. Okay, so now I can go down and actually graph this, right? So they already have kind of a ghosted in image of the original. Again, that's just for a point of reference. That is not going to be part of our actual graph here. So I'm going to be at -5, -1, -4, -5. So again, what I'm graphing is the white parts, not that middle gray part. Here's my x, here's my y. I'm not using this middle part. So it flies back. Okay, and then -3, -4, -2, -3, -1, -2, 0, -3. 1, -4, and then 2, -3.5, 3, -3, 4, -2.5, and then 5, -2. So we can get a good idea of what this is going to look like if I draw in all of these, use those as my kind of guide to draw my actual graph. What you see is the exact same graph as my original, but it's been shifted down 4 units, which again, we should have already been able to predict, but we're just trying to kind of visually see that connection here. So they're going to start off with the quote unquote easy ones, which we should already kind of know. So not too bad there. If I hop over here, right? So now we're going to do the f of x minus 2. So this gray column is going to be the x minus 2 column. Okay, so don't let this fool you. It's not very hard, but people try to make it more hard than it is. Right? Negative 5 minus 2 would be negative 7. Sorry. Negative 4 minus 2, negative 6. Negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3. Okay, so all we've done is we've changed into this. So now, let's go over here and say, hey, what's the f of x minus 2? Well, I don't know what the f of negative 7 is because it's not over here, right? I can make a guess, but I don't have it, so I don't know. Nor do I know negative 6, but I do know negative 5. F of negative 5 is 3. F of negative 4 is negative 1. F of negative 3 is 0, and hopefully we see the pattern. 1, 2, 1, 0, 0.5, 1. So I got the parts that I knew. These two, I again could make a guess, and I could actually probably find negative 6 by looking. It's probably going to be up here, but I'm not sure, right? So I'm just going to leave those ones blank for right now. And again, yeah, you could follow the pattern, but we're trying to just go off of what we know here. So on these ones, if I want to graph them, the ones that I know are going to be negative 3, because again, now I'm plotting it, I'm plotting the white portions. So the point negative 3, 3. The point negative 2, negative 1. The point negative 1, 0. 0, 1. 1, 2. 2, 1. 3, 0. 4.5. And 5, 1. So if we go ahead and plot those, hopefully it'll be a little easy for us to see what that shift is on this particular graph. So on this one, I had all this, it's the exact same graph, but it got shifted to the right 2, right? Every point is this right 2 from where it was because it's x minus 2. So there's my vertical and my horizontal shifts kind of demonstrated here graphically and on the table. So let's go ahead and hop over to the side here. So here we're going to be, okay, so I think I'm going to copy down the f of x back and forth real quick. Just I'm going to be going back and forth on pages, so I'm going to pause it so that you guys don't have to watch that portion. Okay, so now that we have these listed, here's what we're trying to do. So this is 0.5 of f of x. So here's my f of x values. I want 0.5 of it, or half of it. So half of 3 is 1.5. Half of negative 1 is negative 0.5. Half of 0 is going to stay 0, right? Half of 1 is going to be 0.5. Half of 2 is 1. Half of 1 is 0.5. Half of 0 stays 0. Half of a half is a fourth, or 0.25. Half of 1 is a half. Half of 1.5 is 3 halves, or 0.75. Half of 2 is 1. So that's what I got for those. So now let's plot all of these ones. So again, I'm plotting the white portions, here and here, -5, 1.5. So -5, 1.5, right there, -4.5, -0.5, sorry, so I'm right there, -3, 0, -2.5, -1, 1, 0.5, 1, 0, 2, quarter, sorry, yeah, 2 quarter be up there, sorry, I made a negative, it shouldn't be negative, 3.5, 4 3/4, and then 5, 1. So let's go ahead and draw those out. So this is where it's going to start to look a little bit different. Not as easy to see as the last ones, but visually, hopefully it's making a bit of sense. So what we've effectively done is we've kind of flattened out our graph. Every y value has been halved, so it's now half the distance to that x-axis. So our ones which were 3 are now 1.5, which were -1 are now -0.5. The zeros all kind of stayed, but everything else got halved, right? So I get this kind of squished form of the exact same graph. Now it does have the same x-intercept, which is an important thing, but every other vertical measurement is now halved because I'm just multiplying it all by a half there. Let's take a look at D. So D, we're going to take the same idea, but we're going to say, hey, we're going to multiply the inner part by 2. Okay, so when we do that, take the x, multiply it by 2 first. So that's going to be -10, -8, -6, -4, -2, 0, 2, 4, 6, 8, and 10. Okay, so now we're going to find, hey, what's the f of those? So we can kind of refer back to these ones here. Well, I don't know what the f of -10 is, or -8, or -6, but I do know f of -4. So I can start there. F of -4 is -1. F of -2 is 1. F of 0 is 0.5. F of 2 is 0.25. F of 4 is, sorry, I messed up here. 0 was 1. 1 was, sorry, 2 was 0.5. 4 was 1.5. And then 6, I don't have, so I don't have this, this, or this. Sorry, I got off there. That's my bad. Okay, so I only have a certain amount of these, but let's graph the ones which I do know. So I know I have the point -2, -1. I have the point -1, 1. I have the point 0, 1. I have the point 1/2. And I have the point 2, 1.5. So this is the one that gets a little bit messy, and I'm really not a big fan of how the book does it, because we miss out on a whole lot of these points, which we actually need to get a good graph of it. But what I'm doing here is I'm squishing everything horizontally by half. So if I look at just the peaks, this peak got moved here. This peak will move over half the distance, so it's right there. This peak got moved over half distance, so it's there. And then it's going up there. So what I'm going to end up getting is this kind of a shape. And this would actually go up. So again, pretty steep there. Okay, so that's kind of what it would look like. So what's happening here is we're horizontally getting kind of squished down, so we're half the actual width as we were. Sorry, fly. So we're half the width, so everything got compressed to being twice the distance close towards it, which is kind of the opposite of what you would think. Here, 2 you would think is going to make it more wide, but it actually makes it more narrow for us because we're effectively getting to our x values twice as fast as we otherwise would, which is why we're going to be getting to these peaks sooner than we would normally. So let's take a look at part E here. We're trying to figure out, hey, what are some of the rules which we have kind of encountered here. So we have 4 different things we've measured. We have A, B, H, and K. So our A, that's like our 0.5 here, right? That caused the vertical expansion and contraction. Our B, that caused horizontal expansion or contraction. H, so that was the stuff that we added on the inner or the outer parts. That was like we had here. H was here, which caused us to do a left-right shift. And then K, that caused our vertical shift. So those are the kind of 4 parts which we know. Now, I'm going to be a little bit more specific on all of these. A little bit, let's see all that at once. Okay, so on our vertical ones, if I multiply it by a half, I got half as tall. If I multiply it by 3, I would be 3 times as tall. The horizontal, when I multiplied it by a 2, right, I got half as wide. If I were to multiply it by a half, I would get twice as wide. So that one's going to be opposite of what you would normally think. So I'm going to put a little, hey, this one is, sorry, that fly is bugging me for a while. Opposite. It's the opposite of what you would normally think, right? So you think, hey, times 2 is twice as big, but it's actually half as big. Times a third, 3 times as big, because it's the opposite there. Then H, my left-right shifts. Right? So here, sorry, -2 moved me right 2. So this, again, is going to be opposite, right? It's opposite of what you would naturally think. And then K caused my vertical shifts in the way which we would think. So the general rule that I try and point out is if it is multiplying, it's going to be stretching or contracting it. If I'm adding or subtracting, that's when I'm going to be moving left, right, or up, down. Those are my shifts. Right? So, and then both B and H, those are my horizontal parts, my left, right stuff. So and those are always going to act the opposite of what you would naturally think. So again, This 2, it's horizontal, but it's going to be the opposite of what I would think, so it's going to be half the size, not times 2. And likewise, here, it's minus 2, so it's going to be horizontal, but it will be to the right 2, even though minus is typically left, right? So those are the rules that I want us to kind of get right now. All right. So that's it for that portion. Let's hop back over to our PowerPoint. Okay, so we got that graphing form. Awesome. Okay, so let's take a look at this function here. So what would this look like if we were to do these alterations to it? So what I want you to do now is pause the video and try and sketch or figure out what this graph would look like if we did these 3 different things to it. So the first one, we're going to put -1 there and plus 2 there. What would it look like? Stuff like that. Go. All right, now that you've tried those out, what we should get here is this first one on A, is this -1 would actually move everything to the right 1. So every single point here is right 1, and the +2 is everything is 2 higher. So it gets shifted right. Sorry, I'm trying to mirror it so that it looks right for you. It goes right 1 and then up 2. Right? And then on B, that -2 that we multiply by, it's going to be vertically stretched to be twice its height and then gets flipped over entirely because of the negative. And that +5 will shift everything up 5 higher. Okay? And then on C, that 0.5 will actually take it and expand it to be twice as wide from the y-axis. So this point here actually won't change, but the point here would go from -3 to -6, and then it gets wider a lot slower on both sides there. And then that -1 will take everything and shift it down 1 unit. Okay. All right. Real quick little thing about some notes here. Even and odd function, we talked about these in previous times, but an even function is going to be when our f of x is equivalent to our f of -x. So here's a little bit more formal way of showing that. It's also going to be graphically symmetric over our y-axis. And then for an odd function, our f of -x is equivalent to our negative f of x, which again, here's a little bit more formality on that. But graphically, if you do a vertical flip, you get the same result as a horizontal flip. So that would be an example of one of those. Okay, and then here's our closure. Sorry, this fly is making me a little bit angry. So what we're going to do is take this function, which we had back in number 31. Go ahead and write me a piecewise function for this, and then we're just going to disregard the transformations of it right now, just because of we've done enough of those for today. So go ahead and pause it and try and write a piecewise for that particular function. Okay, so now that we're back, let me grab some scratch paper here, and we will graph this, or write the piecewise for it. Zoom out a little bit. Okay, so for the first portion of our graph here, we're going to be, let's point out so I can show you a little bit easier. I want this equation right here. So my slope here is pretty obviously 1. If this kept on going, I would be there, there, and there. So a slope of 1, and I would cross at 5. So this would end up being y equals x plus 5. There's my kind of first graph there, right? And then my second one, that's just a horizontal line at 2. So that would be y equals 2. And then my third part of my line over here, slope is a -1, that's pretty easy, and then I'm crossing here at 2. So then I would have y equals -x plus 2. Okay, so that's kind of what I got. So let's go ahead and write this as a piecewise function. So I need f of x equals, and I'll do my little curvy bracket thing, and then I'm going to have the x plus 5, the 2, and the negative x plus 2 as my different portions of it. And then, what are my domains for each of those parts? Well, the first one, this is going to be every value that is less than negative 3. So for all values of x that are less than negative 3. Okay. And then my middle portion, that is from negative 3 to 0. So negative 3 to 0. Okay. And then lastly, this is going to be from 0 and larger. So whenever my x is larger than or equal to 0. So the things that we want to keep in mind is that there's no overlap here. So this is not or equal to, but this one is, and this one isn't, and this one is. So since they all meet up, I could change it and put this as the or equal to and this not, and vice versa here. But as long as you don't have two things trying to give you the same domain, it doesn't really matter as long as they intersect. So that would be a piecewise function for that particular part. And then if I did want to go ahead and write a corresponding function for each of these things, I would just do all of those transformations on each portion of my graph individually to get my piecewise function being transformed. You're not going to be doing that a ton. They just wanted to show you, hey, here's how you would do it. But again, don't stress out about that kind of stuff. Okay, so with that, let's hop back over here. And here is our homework for 2, 1, 3, 34 through 41. See ya.